This oral history records an interview with Dr. Richard K. Oswald on February 29th, 2024. My name is Ron Dennison, and along with my partner here, Dal Allen, we will be conducting the interview. Dick was responsible for the first track following servo, invented by him at IBM and used in the 3330, later described by Al Shugart as one of the four most significant technical developments in the history of mass storage. Track following, that is, positioning the heads based upon information recorded on the disk, allowed tracks to be closer together, thereby enabling increases in capacity. Ultimately, all hard disk drives adopted this technology and extensions to it. Further, the 3330 family of products as a part of the IBM System 370 was, in its time, believed to be the most successful product family in the history of commerce. Dick continued his outstanding technical contributions at IBM on the 3340, which introduced another of Al Shugart's most significant events in mass storage, the low-cost, low-mass, lightly loaded, or Winchester head. His career at IBM went on to include contributions to the system design and electronics for the 3350, 3370, and 3375. After leaving IBM, Dick became a well-respected consultant to the hard drive industry, solving problems and creating new technology at most of the major hard drive companies. Subsequently, his career embraced both teaching and work as an expert witness. One of his final engagements was here at the Computer History Museum as a member of the RAMAC team that restored to operation one of the last surviving examples of the world's first hard disk drive. So with that, let's begin. Dick, tell us about your family background, where you were born, grew up, and went to school.
Okay. Actually, I grew up in my home till I went off to school was a farm in northwestern Ohio. And up until the second year of schooling at Ohio State, I had planned to probably work as operator of the farming enterprise and have an outside job in the winter. But I got seriously hurt 2 years into engineering school, and that sort of changed the direction. Well, maybe I ought to just forget about farming. So basically, that's what I did. Up until I completed college, I still lived in Ohio, and really the jobs that were available were either the East Coast labs or the West Coast. There was nothing else available. And I had a lot of problems with allergies to things that grew in the Midwest. So it seemed like the right thing to do was go to California. And California was a very pleasant place to be in the 1960s. The infrastructure was there, and it was an entirely different place than it is today.
Who were the people that most influenced you as you were growing up?
Well, I don't know that anybody had a significant role. My parents were supportive of what I wanted to do, but didn't direct me into any specific areas. And where I went to school, elementary and high school, was very small, although by the local county standards was one of the larger of the schools in the county. But still, there were 29 people in my graduating class from high school, and we had no such thing as counselors or any materials of that sort to go by. So I was pretty much on my own in deciding what to do.
What led you to choose engineering?
Oh, I from early days, I always was interested in applied type of engineering. I never really ever got interested in what you would call research and that sort of thing. But I guess the best descriptor for it would be applied engineering. And I got a pretty good background for that. You're basically on your own on a farm. I mean, if something breaks, you fix it. You don't spend half a day going to town and try to find somebody that bumbles through it.
Understood. But that said, I noticed you went on to get a PhD while you were at IBM. What was that experience like?
Well, that was really a pretty good opportunity. IBM San Jose lab had been started about when I got there about 10 years before. And a number of the engineers there had gone through master's or doctorate programs. And initially, when they first started the labs to get trained engineers, they paid full ordinary salaries to attend school. That was your job. Go and learn the things you need to know. And by the time I got there, that was being phased out. And I got basically some support from IBM, but I probably paid over half of my living expenses and costs of going to school on my own.
Okay. We've mentioned IBM. Was that your first job after graduating Ohio State?
Yes, I think that's the first non-farm job that I had. And I worked one summer at the IBM lab in Lexington, Kentucky, which was, quote, ordinarily referred to as typewriter division. And they made typewriters, but also other stuff too. And they had a good mechanical engineering facility, which was typical of all of IBM in the earlier days. And that was an experience too. And I would say regarding Lexington, Kentucky, that's supposedly the bluegrass area. But in reality, to me, it was nothing but ragweed. I never spent a more miserable summer than the time in Kentucky.
Oh my goodness! So, what you went to IBM in San Jose? What initially did you work on?
Well, initially I started in General Products Division, which is kind of descriptive of what the work is. But the major emphasis turned out to be process control and what was, referred to as direct digital control. And what I worked on were basically the process interface. And I think, in fact, I got a patent on a configuration for a thermocouple transmitter, which turned out to be very popular. And when IBM got out of that business, Humble Oil bought the rights to it and continued production for several years on what I had done at IBM.
Well, since we're talking about IBM, and Dal first met you at IBM, Dal, maybe you'd like to step in now and carry on a bit.
Well, I think the thing I remember, Dick, is that if anybody had a servo problem, they called you.
Yeah, that was sort of true.
Yeah. In fact, that wasn't just at IBM. When we knew each other well at ISS, and I thought you were just one of the guys. I didn't realize you were consulting to us because you were in every project that I was involved with. I was justifying the marketing of it, and you were working on the building of it. And then when I got into my own business, I found out that I saw you everywhere I went, to every startup, to every successful disk drive company. You were in a corner over there, working on something for them. So you've got a much stronger background in working with all of the companies in the Valley at the time. And also, with each of them, you filed patents along the way. And so you weren't just working with them, you were actually moving forward on the technology all the time.
Yeah, I think that is quite accurate. I was involved with a lot of, as you say, a lot of drive companies, but notable ones that I didn't ever really succeed in making any contribution that they really wanted were, in particular, was Maxtor. The Maxtor operation, basically the NIH was just horrendous. If it wasn't something that the key guys at Maxtor came up with, it wasn't worth considering. Even if you pointed out things, a way to do it better, that's different, we don't want to do that. And I think that's really pretty much true. I never really worked with HP in the San Jose area, but I did work with their disk drive division in Boise, where they built Kitty Hawk and a couple of other products that were somewhat unique, and there was not the aversion to outside ideas for how to do things there. And one of the things I can still recall is the lack of coordination between the different sites at HP. For example, they were trying to build a servo writer for their product that they were building in Boise, and they didn't know that internal to HP was production of the best laser interferometers for use in a servo writer. They had no idea of the Santa Rosa division or the operations in the Bay Area in Boise. They were on their own. And they reinvented the wheel, essentially, in their disk drive business.
That's very funny. I worked at Santa Rosa division, and I well understand what you're saying about the culture. Yeah, we didn't know what was happening at Boise. And
and they didn't know what was going on other places either.
Let's go back to IBM, though, and talk about your work that ultimately became the track following servo on the 3330. How did that start?
Well, I never really got that deep into the 3330. The 3330 was basically almost ready for production when I went to Cal Berkeley. And while I was there, it was basically announced. And which was typically about a year before they actually shipped it. I don't know the exact dates anymore. I didn't look that up, but it was roughly 1970. But they really had the design completed by 1968 when I really was available again in IBM.
But the track following servo was?
The track following servo, the encoding was actually set up by George Santana several years earlier, and I didn't have a role in it. It was basically a pattern that involved full die bits, and the sync fields were very complex. In those days, prior to integrated circuit electronics, it was rather extensive and expensive electronics required to recover the clock from die bits, all the same polarity and same spacing. It was nice in that it had very little harmonic content, was not sensitive to edge reading on the slider and things of that sort that plagued. And I knew what I was getting into, but purposely 3340 was a much simpler pattern using alternate polarity die bits, which was much easier to clock and simpler to use, but it had a problem that it had a lot of higher harmonics, and it was sensitive to response of the basically the lower level response of basically every edge of the slider reads to some extent. And notable in that regard is a 3330 used a non-magnetic ceramic slider on the servo head. All the data heads were ferrite.
Let's see, subsequent to the 3340, you worked on the 3350, 70, and 75. Any comments on those?
Yeah, the 3340 was intended to be a replacement for 2314. It was to be much lower cost, higher capacity, and would be a direct replacement for the 2314, because the 3330 was just too expensive for a lot of customers. So they needed a different product. And the other things that IBM had to offer were some of the older stuff, primarily done in England, that was cheaper, lower performance, mainly stepper motor positioners, and they needed a better product. And originally envisioned, the 3340, of course, was a removable data cartridge. And this was largely the way that customers used the prior IBM products, including 3330. The disk pack was removable. You had many disk assemblies per disk drive. And for example, in the banking business, a lot of places would update their central records by once a week, bringing in the data cartridges from all of the branch banks and updating their home office records. And one of the things that I can remember from those days is that they had initially in 3330, which was not the first pack drives. I mean, 2314 was also a disk pack. But the configuration there, you were talking about some really much closer tolerance, higher track density. But the way that the operators treated them was pretty brutal. The packs would come in third shift in the middle of the night, when there was basically no management around. So there were just the guys that were supposed to load them onto the drive and update the data. But it was, probably 100 yards from the data center to where the delivery truck arrived. And a 3330 pack is about 25 pounds. I mean, it's not a trivial thing, a 14-inch disc. And so to speed things up, they would get off the delivery truck and walk over to the loading dock and launch them down the hall to the data center, not carry them, but slide them, under just as a dead weight. And the guy at the end would grab it and put it on the drive.
Good grief. And
they wondered why, it was designed for a reasonably rugged structure, but it was not sealed. It had a cover which was removable, and it used ambient air for operation. It didn't really have any sort of filtering system, and it was ruggedly designed. But it wasn't quite up to the way it got treated.
So, talk a little about the culture at IBM and the folks that you met there.
Well, in the earlier days, including till about the 60s. The environment there was kind of a close-knit, paternalistic sort of thing, I guess you would describe it, which was similar to the New York labs that were started by the Watsons, and they had what was called the homestead, which was an on-site place like a resort motel for customer training. And, nobody else in the business did anything like that. And that was an integral part. It was, they had a 9-hole golf course as part of it, and they treated customers and as well as employees very well. Formal pay and benefits were not significant. In fact, they were probably below most competitors, but there were a lot of unstated benefits.
Perks.
In addition to the regular salary and so on. And they were strictly no layoff policy. And a big turning point was the economic downturn of 1971-73. And at that time, the order backlog for disk products just went to nothing. And there were a lot of people in manufacturing as well as engineering that had nothing to do. But the company would not lay them off. Even if they'd come in and sit at a desk for 6-8 hours a day and not do anything useful. But they still were maintained. They got their regular pay and were treated as an ongoing employee. Now that environment, a couple guys, I wasn't really involved in that part of it so much, decided, well, gee, there's all these engineers sitting around not doing nothing. We ought to come up with something useful for them to do, and that's the way the 3350 product got started. It had no budget, was never officially recognized until about 3 months before it was announced. And the customer engineers and the customer sales force were so anxious to get another product that was more competitive than the 3330 that they grabbed it and went. And the upper management in back east insisted that, we're going to sell 3330s and maybe this low-cost 3340, and that'll be it. But the 3350, because there was no budget for hardware, largely used 3340 parts. All of the castings and those sort of things which involved any sort of investment were deferred. And for example, the base plate and a lot of the other assemblies were actually slightly modified 3330 type of parts or 3340. The base casting and some of the stuff was really 3340. And in fact, I can recall, because it was announced and shipped within a few months, which was unusual for IBM products, the plug compatible guys didn't have time to tool up castings. Most of them had not participated in 3340 equivalents. And I can remember one show at the Anaheim Computer Conference when the customers were very specific to avoid allowing anybody to look too closely at their prototype product that they had there on display. But when they all went to lunch, a couple of us guys were snooping around, and the guy that left didn't really be informed what he was supposed to do. Oh, can we have a look at this? And he opened the back cover, and the logo was still on the casting, the IBM logo. Okay. They didn't have time to turn out a second source for the casting, and they used IBM parts in the first drives they shipped.
In the plug compatible.
Yes, as a plug compatible to 3350.
And those days that would have been what, Memorex and
Control data
control
primarily.
data. Yeah. Good grief. Talk a little about the 3370. That was the first thin film head drive, right?
Yes. The intent was that they were going to use film heads and disks on 3380, but it didn't materialize. And there was a well-known bias around IBM. You don't change the head and the disk both in a product. So film heads went in, but thin film heads, which most of the rest of the industry was using, as well as film disks, the film disks were not part of the IBM product. In the case of 3370, it was still particulate disks, just like 3330 and 40 and 50. And as I say, most of the plug-compatible guys were both film heads and film disks. The film heads, of course, were made internally, and actually were cheaper and easier to produce after they got in production than the hand-wound film heads. The original plan on 3340, which used a tri-rail rather than a two-rail slider, was that it would be machine wound, the read-write coil on the film head. But it turned out that the guy that developed the process for that left, and within a couple of months, the line went down. They couldn't do it. It was a very challenging job to wind the coil in the miniature head, and they went back to hand winding. And most of the production for 3340 was all hand wound film heads.
Good grief. Talk about the contributions that you made in terms of control and electronics over these product generations.
Okay. The 3350, as I sort of related earlier, was kind of a bootleg sort of project that wasn't really funded as a formal project. And the same thing was true. It was supposed to be inexpensive, and it really cut corners to some extent in the hardware in the servo system. And the fellows that developed the 3330 and went on to the 3380 invested a lot of effort into really expensive top-of-the-line hardware for their servo system, and their settling time was a lot worse than what I was able to get out of the old hardware on the 3350, which was, basically old stuff, and it was designed to be cheap, but still adequate to do the job. As opposed, the 3330 and 3380 were top-of-the-line products that really probably a bit overdid it in terms of what was really needed in the way of expensive electronics in particular. They were still pretty much discrete components rather than ICs. 3350 used the ICs at really smaller scale in terms of complexity. Ones that were in the 3340, plus a couple new ones that went into the servo system, and also the read-write electronics were low-level integration rather than discrete components, as it was true. 3330 was essentially all discrete components, and it introduced a few 741 op-amps in the servo electronics, but most of it was bare transistors.
You hold over 24 patents, and a number of them at IBM, but then a number also at other companies in the industry. Are any of those stand out particularly in your mind in terms of the work done or the innovation?
Well, a lot of the work done at IBM, management chose to put out as trade secrets because having the detail that you needed to put in a patent made it easier and faster for the plug-compatible guys to copy it. So as a result, probably the servo encoding and a lot of the other stuff, the way to get function out of low-cost, semi-integrated electronics, was of significance that I could have gotten a number of patents if they would have chosen to do things that way. But instead, it was trade secrets. So I don't believe I got any patent coverage in any of the later disk drive work. There were a couple things, I guess, that were covered, but the vast majority of it was treated as a trade secret and never put out as a patent. Some of it was in the technical disclosure bulletin, which IBM had on purpose in order that things be published so that nobody else could patent them, but not in sufficient detail that you could use them as a head start on building a copy or implementation.
Yeah, I think I still have the technical disclosure bulletin for the 3380.
Yeah, I think it's unfortunate that management decided to discontinue the technical disclosure bulletin. They also, in the early days of the internet, IBM chose to make the entire catalog of patents in the patent office from day one, back in the 1800s, available free on the internet. And as times got tougher and they discontinued their no layoff policy and otherwise saved money, as the control of the company shifted from basically engineering-based to sales and MBA sort of people, there was a lot of cost-cutting sort of things. And one of the things to go, no longer any free patents accessible on the internet, no more technical disclosure bulletin, no more continuous perks, and no layoff policy in the manufacturing area in particular. So there was a big change. The last basically engineering-trained CEO for IBM was in the mid-'70s, and it changed the entire culture of the lab. Emphasis was put on research division instead of the product divisions, and just the way of going at things. You did not have the freedom to invest in development. It was really, put a minimum amount of sort of packaging and things you had to do to get a product out, and no more to save money, and everything to cut corners in cost, but still get acceptable performance. Was the standard of the day, starting about the mid-'70s, with 3370, for example, is the first product that was exclusively metric dimensioned in all of the manufacturing documentation. Prior to that, 3330 and 40 and 50 were all dual dimensioned. All of the drawings were both metric for the rest of the world as well as English for the U.S. Market, and upper management dictated no more English units on any drawings. Everything is now metric. And it was a major undertaking, and basically the model shop, the development, hardware development in the San Jose lab became overnight obsolete because it was all based on inch tooling. And we had most of the tooling for the 3370 was done in Europe, in Germany, specifically because there was no tooling in the development areas that was metric dimension and could be used for the development hardware.
Good grief. That brings us to around 1973 when you left IBM.
Actually, in 1973, due to the hangover of the severe economic sort of panic of 71, 73, I had a lot of time on my hands too. So I started up just a sideline of consulting practice, which was very narrowly focused, not to really infringe on the major sort of technology developments that IBM had done, but more general engineering and just the nuts and bolts sort of things that you had to do to get a successful product out. And there was plenty of need for that. And for about 5-6 years, that's what I basically did. And I put in a full day's work and a little more at IBM, but it was 8-9 hours instead of 12 or 15, as had been previously the case.
So then that's from 73. So you didn't actually leave IBM
I didn't leave
until
IBM
79?
until 1979. And it just got to the point where I was doing more on my own, and the folks in research and corporate level of IBM were convinced the disk drive is dead end. There's no point in ever developing anything past 3390. And as a result, basically the development area of General Products Division was shut down, and there was not any really good stuff to do. I was not really that interested in the advanced technology, sort of in quotes, pursued in the research division. I was more interested in applied engineering, and I just decided that the way things were going, there was not much future in IBM anymore, and I ought to at least do a regular sort of broad-based consulting work, including the current technology that I had not gotten involved in up to that point purposely to avoid potential conflicts. So I really started the consulting business full-time when I left IBM, and except for a couple stints of a few weeks, I've never been an employee since.
In fact, you've consulted for quite a number of the leading data storage companies, including Quantum, Data General, Control Data, Seagate, Syquest, Maxtor, Memorex, HP, Matsushita, which was Panasonic in the US, NEC, Hitachi, Siemens, Nixsdorf, Toshiba, and so forth, in addition to a lot of other companies in related industries. Talk about some work you did at Maxtor. What were some of the projects you worked on?
Well, really, Maxtor started when the product line and the emphasis in quantum changed drastically when the founders, the Moon Brothers, and some of the other key folks really no longer had control of things, because the board of directors, the founders were hands-on involved in many of the everyday sort of things at Quantum, and they brought in an MBA graduate from Stanford to run the business. Quantum was almost as paternalistic as IBM. All of your travel, domestic as well as international, was business class. It was not coach, and similar sort of things. And this just was all out of place with the MBA schooling of how you cost effectively run a business. And so it was, as I recall, roughly a year after the founding folks at Quantum retired, and control passed to basically the MBAs instead of engineers, that it was bought by Maxtor, which realistically, Maxtor, in my assessment, was not a top-notch technology company at all. The NIH there, the not invented here syndrome, was such that all of the suggestions I made, which really I was well convinced were really needed, were completely rejected because one of the principals at Maxtor didn't come up with it. They basically they refused to use any of the quantum technology. Basically, when Quantum was sold to Maxtor, what was sold was the disk drive part of it. And at the insistence of the later management, Quantum had gotten into the tape business, and they retained it. And to this day, Quantum is a tape company, and they do not do any disk drive stuff. So the disk drive division and all of the stuff that was developed, the products developed at Quantum, were rejected by Maxtor. Any sort of thing, they would not invest, for example, in any manufacturing automation. They didn't want the capital investment. So a lot of things that were done in the rest of industry by automation, they still did by hand. And they did have a domestic manufacturing facility in Colorado that probably, at least initially, did a lot of their assembly work, but it quickly went totally to Asia and was just a sweatshop operation. And they were not really interested in pursuing any sophistication as a means of including higher densities and things that would involve technology development. And since I had been working at Quantum, I sort of got involved with Maxtor, but I was not able to make any meaningful contribution there at all. Just all of the ideas were rejected if they didn't come from Maxtor people.
Did the manufacturing arrangement with MKE survive that merger?
No.
That's what I thought, yeah.
None of the MKE assembly business. Maybe it's worthwhile to digress just briefly on MKE. MKE is Matsushita Kotobuki Electronics. And basically, they had a virtual worldwide lock on the cartridge, the VCR business. And they had a lights-out factory in a small island south of the main islands in Japan, which assembled VCRs. And literally, it was lights out. They had a loading dock. They brought in the components, and they shipped out the finished product the other end, and no human hands touched it in between. It was a very, very effective manufacturing automation, and Quantum had not had good success working with Jabil as a third-party manufacturing operation. To make it cost-effective, they got subsidies to establish a manufacturing facility in Puerto Rico, but the workforce there was not, it was not like Japan, for example. You couldn't really say that the capability of the workforce was inferior. It just the middle management, the direct management of manufacturing was not well done by J-Bill. And the Quantum, still, this was the founding group at Quantum, were still in charge, and they started looking around. And Matsushita management saw that the VCR business is tapering off, and we've got this nice automated factory here that we invested a fair amount of capital in, and pretty soon we aren't going to have any VCR product there. So they worked with Quantum to negotiate assembly of disk drives. Now, MKE had no experience whatsoever in the disk drive market, and I can remember working with the guys at Quantum, and they were very worried. We're going to get these amateurs assembling disk drives with no experience, and they allotted 2 days to build the initial lot of prototype disk drives that were then in production in the Matsushita facility, and they got them totally assembled in 2 hours and had no rejects. And the first time that the workforce had ever done a disk drive. And it was really, I think I maybe went to the manufacturing facility twice, and it was very difficult to get there. It was located in a fishing village. Ipamatsu, in a southern island of Japan. And there was no way to get there by public transportation. I can remember still one time when I went there, and it was just I think there were 2 of us that had worked at Quantum in Milpitas that were there to, I don't remember now what the issue was anymore, but we must have negotiated a half an hour with the taxi drivers at the end of the road in Japan to take us another hour to where the factory was. And oh no, we'll never get a return fare because, what's there? There's the Matsushita factory with maybe half a dozen people, and, because it's all automated. And there's, it's just a fishing village, and there's no reason that there's going to be anybody there that would want a taxi ride back to the north to where the populated part of Japan is.
Yeah, I was there several times working on servo-track riders.
Okay.
Yeah. Another storage company you worked for, consulted with, was Seagate. What was that like?
Basically, I helped Seagate get started when it consisted of Al Shugart, Finus Connor, and a high school girl that kind of filled in for the office work. The ST506, the first product, was the brainchild of Finus Connor, who was a just amazing, knowledgeable marketing guy. And his idea is we build a low-cost disk drive for mass storage on PCs. And at that time, he needed the means for a startup to build it, because nobody in the industry thought that you could put a regular disk drive on a retail sold PC. And Finus' idea was well worked out on how to do it, and he picked up other people's ideas. The band drive, stepper motor actuator, which was low cost. Actually, the pieces existed, but nobody had ever used it before. And basically, the whole first product, the ST506, 5¼ inch drive for attachment to PCs, was designed by what you would like to consider to be consultants, but they were actually engineers that regular job was at Memorex or Shugart Associates or somewhere else, and in supposedly what was their spare time, but really was the main job, is they designed all of even the manufacturing tooling for the ST506 product. And of course, you have to note that at that time, it was not called Seagate. It was Shugart Technology, ST, Shugart Technology. And they had no budget, no backing. It was a startup. And they needed a certain amount of equipment like oscilloscopes and basic lab gear. So they would call up the distributor, or in fact even HP, and says, "Oh yeah, we could use this and this and this." Well, gee, who are you? "Oh, we're Shugart." "Oh, you're that part of that Xerox company." "Oh yeah, you got good credit." And they just shipped the stuff, and they got all of the stuff just on the word that, "Oh yeah, we'll pay you." But they really had no backing. And finally, the Xerox lawyers got wise. You can't use the Shugart name. Shugart Associates was the name of the Xerox operation building 8-inch and floppy drives. And but Finus had this all figured out ahead of time, and even the logo was still ST, but it now was Seagate Technology, not Shugart Technology, at the insistence of the Xerox lawyers.
That's an amazing story. Did you go on to consult with?
I never really. I was busy with other things during most of the main, expansion of Seagate into a real, full-time, significant power in the disk drive business. And later on, I worked with them, but the primary job was training engineers in the current technology. They were very short-handed in terms of technical people, and never really had a good development operation for their products because of the way that the early stuff got started with basically everything done by third parties. And that was my prior, involvement and participation with other companies was much different. With Seagate, it was mostly training their engineers out of school of what's a disk drive, which you didn't learn in engineering school.
No. In fact, I can recall a number of companies had presentations called like Disk Drives 101, right?
Yeah, and that's what it amounted to. And a servo surface and the encoding and how to build an optimal time controller and so on. It is, established technology, but it wasn't taught in engineering schools. And there was a big demand for that sort of thing.
Yeah, I even did some of it.
Yeah, I imagine so.
We talked about Quantum and Seagate. Are there other companies that you found memorable that you consulted for that you particularly thought you made a great contribution at, or they were particularly good to work for?
Well, I guess the other major thing that I got involved in by about probably the 1990s, early 2000s was issues for intellectual property and patents and infringements with law firms, as well as rather than just hands-on hardware engineering, a lot of it was direction. For example, one of the maybe memorable things, I spent about a week with the Siemens board of directors in Munich. Siemens was building, an unbelievably high-class disk drive module that was competitive with 3380, but just went a lot further. It was, built like a tank, and had to have been very expensive. Even though they had a reasonable quantity of business in Europe, they still were probably losing money on every drive shipped. And so their board of directors was assembled. What do we do about it? And so on. I mean, Siemens is into everything. I mean, they're a big conglomerate in Europe. Bosch is a division of Siemens, and they have a lot of stuff in automotive electronics and just electrical things. In industry, they build trains and ships and heavy sort of things. They build electronics, and they were deciding, well, we have some capital to spend. Do we really go into the computer business in a big way, or do we do something else? And they decided that, after quizzing me around, what's it like to do this, and this, and can you really participate in for example, the disk drive market and so on? And my advice, and it was pretty obvious, there's better things to do. So the outcome of that later, and I didn't know about it at the time, is they started in Infineon, which is they split off the semiconductor division as a separate subsidiary company. And it's not based in Germany where things are too expensive. It's based in Austria. So that was interesting. And Siemens was an interesting place. The people I can still remember the fellow who worked at the corporate level, who was basically an officer in the German Air Force. And he took us around the various places, and those nasty Americans, they bombed this building and just ruined things. And I said, just out of sort of aside, you ever been to Coventry?
We've talked a little bit about this already. Are there any other memorable people that you worked with as a consultant that stick in your mind?
Probably I can remember better some folks that were lawyers in that part of the business, rather than specifically, direct engineering.
Bit.
So that's worth talking. The other thing, while you're on the subject, so far as people, especially from IBM days, that really had a lot of respect for, and they had something to contribute, was Jack Keeler, which not too many people were aware of. He was a manager at the San Jose operation, and then went back to corporate headquarters, and unfortunately died. He was a pilot as a hobby, more or less, and he died in a plane crash, and he was sorely missed. I can still remember once we were demonstrating some hardware that was destined for the 3340, and we're fussing with a storage oscilloscope, which in those days, it was all analog. And it was, operating a storage oscilloscope was not trivial. And it was taking a little time, and Keeler became impatient. I can do that. And he walks over and sets everything up that I and 3 or 4 other engineers had been working on it for 10, 15 minutes. And he walks over and he's supposedly at the executive level, but no, he was hands-on at every level. And I really respected that. The other guy that was of very much interest was Bob Friesen. Friesen was an engineer initially, and he developed the low-cost drive technology in England. He spent a lot of time in England, but when the original crew doing 3340 left, he took over, and he had really an amazing knack for how to deal with the bureaucracy. His contribution to engineering was not the hardware, but, we got a problem, so-and-so won't let us do that, and we can't get this. I'll fix it. And he always did. He was just really good at that. And basically, later on, he had an executive position at corporate headquarters, and I kind of lost track of what he was doing. But he was an amazing person, that he had a background, he knew what was needed from an engineering point of view, but he was no longer a hands-on engineer, and he was making a far bigger contribution by dealing with the big company bureaucracy. And really, and of course, I guess you got to consider one of the guys was Al Shugart. When he was still at IBM, he was a second-level manager when I started, and initially worked there. And a lot of the stories about Al were not exaggeration. I mean, he did things his way and not by protocol, and was always at odds with management back east. And he literally, he had his weekly sort of conference get-together with all of his people across the street from a plant site in the Oasis Motel bar. And this was true. I mean, this wasn't a made-up story. That's where he went. And he never would wear a tie and a suit coat. He would always show up with rolled-up shirt sleeves, and whereas everybody else in the company, just by protocol, you had to wear a jacket and a suit and tie. And no way he was going to do that. And he left for Memorex about just before I went to school at Cal full time. And things changed a lot when he left. He was involved in Minnow, which was the original flexible disk drive, and at IBM it was viewed as not a product whatsoever, but an internal way of distributing microcode to the field. And basically, Shugart, it is operation at Shugart Associates, turned it into a product. And the aftermath of that was that there were outright raids on the technology, not so much for the regular disk drives, but for the floppy drives. And one weekend, the prototype Minnow disappeared from what was considered a secure lab. And after that, they put key access locks on all of the doors to the labs and started to really enforce security, and there was none of that prior to that.
Yeah, let's just clarify the Minnow was 8-inch, right? Because Shugart Associates'
Yes.
first product was an 8-inch floppy,
Yes.
right?
And, well, Shugart Associates came up with an 8-inch rigid drive also.
Yes.
And that was copied as a plug compatible with one of the products, Dolphin, which originated in England and was a predecessor. It was 2314 technology with both voice coil and stainless band stepper motor access, and used cartridges. And the Dolphin was in a drawer like 2314 and 3330. for packaging. And IBM domestically never did a 210 millimeter disk part. There were two common, quote, 8-inch disks. They really were all metric dimension. There was a 200 and a 210 millimeter disk, and they had different size center holes. And to prevent warpage and so on, the IBM version used the large center hole so that the clamping didn't distort the disk surface, and they coexisted for a long time. And a lot of the plug compatible folks did make the large center hole ones, although you could get a lot more capacity, and most of the well done stuff was the small center hole.
Yeah, I remember the ANSI standards for those.
Yeah, I'll bet you did.
Anyway, let's see, we talked about memorable people. Tell us about your teaching at San Jose State.
I never taught at San Jose State and never had any association with San Jose State other than Art Wagner, who was a professor of electrical engineering at San Jose State, and Ken Wasson, who was a magnetics guy, more manufacturing oriented rather than development. Worked together, the three of us, on a 2-day graduate level course in disk technology, and it covered everything from academic controls to encoding and detection and construction of linear and later rotary actuators, and all aspects of disk drive technology.
Okay. Starting in, I guess, about the 90s, you worked as an expert witness for several decades. What was that like, and how would you characterize it?
Basically, the way I got a start, and maybe a notable person, was Dave Harrison, who was one of the early folks at Quantum. And he was a lawyer, and he handled all of their intellectual property and patent business. And in fact, he was responsible in a way, I guess, for the fact that it got called Quantum. At the time when they were a startup, and I had still been at that time was doing some work with them, they were going to incorporate as a California company. And it turns out, and I don't even remember the detail of what the name that they wanted to call a company, but the corporate registrar in Sacramento says, no, you can't have that. That's already taken. There's so-and-so company has already adopted that name. So on the spot, Bill Moon comes up, let's call it Quantum. And that's the way the Quantum name originated. Probably an hour before that, he had never thought of the Quantum name whatsoever. But he realized that, I better incorporate as a formal company, and it turned out to be Quantum.
Wow, that's a great story. Any other memorable events from your expert witness work?
Oh, I guess there was a lot of stuff. A lot of it were involved depositions and work to counter infringement claims of various sorts. And that was initially most of the work I did, is working with law firms as a way to handle infringement claims amongst, at one time there were well over 150 companies in the disk drive business in the Santa Clara Valley. And there were a lot of legal actions and infringement claims because of the fact that IBM never patented much stuff associated with disk drives. It was all treated as trade secrets to delay reverse engineering of the products. They hoped to have things ship and be in the marketplace and get the benefit of the early, better paying sort of business before the plug-compatible folks got involved and it became competitive. I know at one time there were at least double and triple density 3330 Mod 2s, and 33 Mod 2 was already a double density of Mod 1. 3330 Mod 1 is the first, or I should say the last product designed with absolute tolerancing. It was designed in a way that absolutely every piece would fit with margin. And they soon discovered that as a practical matter, you could at least double or triple a track density, and probably 98% of the drives would be perfectly fine and offer plenty of design tolerances. So after that, a lot of work went into developing statistical dimensioning for products, and 3330 Mod 2 hardware, Iceberg, was basically identical in most respects to 3330 Mod 1, the main product, but was double track density. And it was done by just doubling the track density with the same parts, and they calculated that maybe one in a couple hundred set of parts would be such that tolerances would be questionable, but that if you just disassembled it, put the parts back in the bins and assembled a new collection of them, you'd probably be fine. And companies like Ampex and Storage Tech and others eventually triple density, which would have been about 5 times the track density of the original 3330, and still had plenty of margin.
That's very interesting.
You know, Juggy Tandon must have learned from that. Because
I think so.
Juggy never had any failed products.
That's
He'd go
right.
to the end of the line. If it didn't pass, broke it down, sent it back to the beginning of the line. So he practiced tolerancing in his manufacturing business.
And Juggy Tandon really devised the double-sided floppy disk.
Yeah, he came up with the head design, yeah.
IBM worked on that for 10 years and were never able, this is in the days of absolute tolerancing, and they could never come up with anything that they felt confident in would work. And Juggy Tandon, with a relatively minor capital investment, came out with a perfectly good product that was double-sided.
Yeah.
IBM never had one.
Yeah, and his factory was down there in Simi Valley.
That's right.
Yeah.
And they were in the rigid business too, eventually, but their bread and butter, and really their contributions were the double-sided floppy, I felt.
One of the last projects you worked on was the restoration and demonstration of the original Ramac disk drive here at the Computer History Museum. Talk about that a little bit.
Well, I guess maybe you would start with how the unit that is here originated, and it's really a pre-production unit that was shipped from San Jose to Poughkeepsie to train field engineers on how to make the adjustments. And,
so it was a training aid, basically.
So on, and the regular unit was an under-the-covers sort of stuff that went internal to another project and product line, and was never built as a standalone. But to make it operable as a standalone training device, somebody in Poughkeepsie designed basically structural steel base and with casters and so on that you see on this one, and that's strictly one of a kind. It's not a production unit, and to the best of my knowledge, was never, no contributions to that part of it were made from the designers in San Jose. So, when 2314 came out, basically, there were the fixed products, the 1301 and 2 and so on, that were still the 24-inch technology, but were head for track and or access in only the radial direction and not the vertical axial direction as Ramac is. So that product sort of got pushed aside in a warehouse in Poughkeepsie and sat for 20 years. And I'm sure basically nobody in IBM was really aware of its existence, but Al Hoagland, who was, then together with Ken Houghton, were establishing the Magnetic Storage Institute at the University of Santa Clara. And he started inquiring around to get a hold of some demonstration hardware that would be suitable to use with his graduate students, and remembered that this prototype Ramac storage, because there's about probably 300 pounds of aluminum castings in the Ramac drive, so it was lucrative to recycle it. And to the best of my knowledge, by 1960, there was no hardware, IBM at least, hardware in existence. It basically had been withdrawn as a product, although there were notable examples of stuff still in use. But it was no longer in production, was long out of production, and wasn't available. So there was no real source to use as a demo vehicle here in the Computer History Museum. And Al Hoagland remembered, there was this training aid in Poughkeepsie, because there was nothing available in any of the regular facilities in San Jose. So they had to sign a formal contract to get that, but they basically transferred it and effectively gave it to the University of Santa Clara for use. And Al worked on it with graduate students for a couple years in an attempt to restore it, the access as well as read-write, to really no significant success. They sort of had something that, maybe had an access time of 10 seconds or something like that. It was very low performance, and the electronics were not really very usable. And a couple guys still working at IBM put together a commercial parts integrated circuit read channel for it, and basically I had spent some time with them this is while the unit was still at Santa Clara. One of the big problems was, of course, Ramac, most of the control functions is not electrical. It's pneumatic. And associated with the product is a built-in air compressor. And the originals, IBM San Jose had two sources for the air compressor, and the dominant one was DeVilbiss in Toledo, who still is in the big recognized producer of spray equipment. and a line of air compressors. But, the air requirements are not very high volume in the RAMAC configuration. And to put a big two-cylinder air compressor intended for use in spray booths, the thing was unbelievable noisy. And it so annoyed people in an engineering building in Santa Clara University that they got about 100 feet of air hose and put it out in a balcony just to get rid of the noise associated with the air compressor. And when it arrived to the Computer History Museum, the guys took one listen to the air compressor. No way, we're going to have this. And they came up with a European-built air compressor whose use, it was a commercial unit used with the airbrush business, very low volume, high pressure sprayers, which at least at the time, 10 years ago, was not very widely used in the US, was much more popular in Europe. And that's what's in the unit, is stock 50 hertz intended drive motor and an air compressor that's very quiet and designed to be used in in the environment of an artist studio for airbrushes for advertising and original artwork, and that's what's here. And if you allow it has a small reserve storage tank for peak use, and it takes probably 5 or 10 minutes from an empty tank to develop. The air pressure used is fairly substantial. It's low volume, high pressure, the pneumatics in
how many PSI roughly?
It's a basic operation. You can get by with about 35, but normally it's about 50 for proper use. And of course, the heads are not the self-acting air bearing of the later stuff. They're externally pressurized heads. And if you've looked at the unit, you can see the air hose, which all we had to replace because the original had cracked and leaked and so on. But the airheads are externally pressurized and establish so you can operate the entire system. And for a long time, after we got it here in the Computer History Museum, they didn't want to invest in three-phase power, which was required for the original spindle motor. So for a long time, we operated it with fixed discs, not spinning. And it works perfectly fine because the air bearing is externally activated with compressed air, and you get a flying head without the disc turning. So, disc turning is actually cosmetic. It would work perfectly fine without ever powering up the spindle. But eventually, before it went on display, we got three-phase power there, and that was I'm sure, the biggest cost. All of the rest of the cost of the hardware restoration was all done by the three or four of us. And it wasn't big items. We, amongst us, we probably contributed a few $100s to.
Did you have to do any electronics design or any?
Yes, the way that we got it was strictly the mechanics, and none of the original controls for the unit were not electronic. The original configuration of the controller was all IBM wire contact relays. And the only thing vacuum tube was the reed channel, and part of the actuator were vacuum tube. The rest of the electrical, you can't really say electronics, although there were some discrete electronics that There were no real source for semiconductors in 1952 when the developments of the Ramex started. So it's the only thing with semiconductors is basically the power supply that I had to build because the original wasn't available.
Well, it sounds like you had a lot of fun.
Yeah, it probably, I think it was about 8 years from the time that we first got the unit that it went on display here in the Computer History Museum. And looking at it historically, the entire product was developed from scratch and went into production in 6 years in the San Jose Development Lab. So it was, it was part-time. Amongst us were basically retired, well, mostly, not entirely, retired engineers from IBM that, it was a spare time hobby and of interest. None of us worked on the original Ramex, except Al Hoagland used to show up occasionally as a consultant. He's the only, when there was a question, well, how did this really get done? Because the parts were missing in the unit we had. How did this get done in the production version? Oh, yeah, I remember this, and was useful, although he was not hands-on. But he was involved in the design of the original read channel in the Ramac, and basically he and George Santana were responsible for example, the encoding of the data code used. It was what later became pretty common, but was not really established. I mean, you were pioneering things in a real way.
Well, it was the first one.
In a rigid disk drive. The Ramac was really the first one. And, a 24-inch disk was chosen on purpose as the biggest size that would fit through a standard office door. Several companies, including IBM, had built previously 36-inch disks used primarily for instrumentation rather than data storage. And that was the only background. And there was no source for the disks. One of the things more time-consuming in the development project was coming up with a way of building a particle disk, a discrete coating rather than a film disk. And they finally came up with their own process to make them. And I can still remember a couple times in the early 60s, part of the operation still existed in an old warehouse. This is actually before I became an IBM employee. There were two guys. You had to have two people present. There were two guys that kept the original unit that was used to coat the disks in this old cannery warehouse on South 10th Street next to the fairgrounds. And the process for several months into initial production was a Dixie cup that you filled with a mixture of iron oxide particles from a ball mill mixed with an epoxy, a brown epoxy, and distributed in a Dixie cup. And the way that you made the discs was a modified potter's wheel that was hand pedaled to get the variable speed, and the operator poured the coating out of a Dixie cup, paper cup, on the center radius, and then speeded up the potter's wheel until it naturally leveled out and coated the disc. And they tried all manners of higher tech versions of coating disc, and nothing worked successfully. And in fact, it was probably well into a year of significant production until they even automated the Dixie cup. Eventually, I think so far as I know, Memorex went into the primarily more the servo writer business rather than the disk drive business at their facility in Santa Clara. And they, one of the engineers there came up with a spray method of coating rigid substrates. At that time, in the early time, there was no such thing as a iron or steel-free aluminum substrate that was suitable for a magnetic disk. Aluminum, was available commercially, but it was made on a rolling mill that used steel rolls. And there were enough flaky particles from the steel roll contaminating the aluminum that it was unsuitable for use in a magnetic storage product. And it turns out that they talked a small aluminum company manufacturer to dedicate a line to making a grade of aluminum that could be made into disk-based magnetic storage products. And in fact, that was true for a long time until the volume got up to the point where it was affordable for the big companies like Alcoa and so on to get into the disk business. Because, to come up with a roll that had a lifetime to produce a reasonable flat aluminum disk that was suitable for use as a storage product was, quite a while, several years, and was really into the late 50s, early 60s before it existed commercially, and never any place except the U.S. There was no source in Europe or Japan or anywhere else for storage grade aluminum suitable for disks.
That's a great story. Are there any other folks that you haven't mentioned who had a big influence on you?
I don't think any in particular are really noteworthy, and more in terms of ones that I do recall and I learned from were primarily lawyers in that part of the business rather than the engineering part of it. Other than disk drive engineers who primarily got their start at IBM, I don't recall any of real note.
This is a got you question. What are you most proud about in your career?
I don't know of any one thing. The fact that I was, somebody that went to high school in a farm area where the high school graduating class was 29 persons, which was big for them. Most were less than a dozen. And at one time in the Putnam County, Ohio, northwestern Ohio, where I grew up, there were 12 high schools, of which 3 were really what you would call public schools. The rest were sort of, they were all parochial school run by the Catholic Church. This was all an area of German immigrant farmers in Putnam County. And the total population at its peak in Putnam County was maybe about 6,000 or 7,000 total population. And the only place of any size by the even local standards was the county seat, Ottawa, which is population about 2,700.
Good grief. That really small town America.
Yes, strict farming area. Although the two places of what you would call cities in the area were Findlay, Ohio, and Lima, Ohio. Maybe Lima you've heard of because it was, and still until maybe the last 25 years, was the largest oil pipeline center in the domestic U.S. And it's not known, but Northwest Ohio was the first petroleum oil field west of Pennsylvania. And there was so much natural gas available from the early wells in the 1890s and early 1900s that the city of Findlay offered free gas to any company that would locate there, and several glass companies actually relocated their headquarters to Findlay. And Findlay glass is kind of a collector's item now.
Interesting. Speaking of where you've lived and living, clearly while you worked at IBM and consulted in the Bay Area, you lived in the South Bay,
yeah,
right?
San Jose. I lived in the same house in San Jose for a little over 50 years.
Wow. But then you moved to the Phoenix area.
Yes.
Why was that? And
basically, the reason that I left the Bay Area was because of what happened to the government and infrastructure. Basically, the legislature passed a law that made it impossible to do consulting engineering anymore. I mean, as a minimum, you had to have a state professional engineer's license, which up to that point was for like utility and building people and so on. It was not like nobody in the electronics area had a professional engineering degree. But if you didn't have a California engineering license, you had to be an employee. You could not be a consultant. And that was the last straw, because not only it affected me directly, but indirectly all of the companies that I worked for, including in particular the law companies, closed down their operations in California and moved elsewhere, mostly to Nevada and Colorado, if not all of the way back to the East Coast, and a few to Arizona. Now, the ordinary people, in 1950, the total population of Arizona was probably just over 1 million. Today, it's like 7.5 million for the whole state, of which at least half of that is in the Phoenix metropolitan area, and probably the majority of it are people that have immigrated from Southern California.
yeah, probably largely due to the rise of refrigeration, right?
Well, refrigerated air conditioning was a part of it, although, you can get along just fine with what's commonly called a swamp cooler, an evaporative cooler, because when the temperature is over 100, the relative humidity is usually less than 10%. And it's so dry that, a glass of water will half evaporate in a day.
Good grief. Tell us about some of your other interests. Do you have hobbies or sports activity? What are you doing now?
What am I doing now? Yeah, basically, in the move from California to Arizona, I did a lot of the moving myself in the SUV and trailer. And when I was unloading stuff, actually, I guess it was January of 2020, I caught my foot under some furniture that hadn't been placed yet, and fell and broke a hip and was laid up in a hospital for a hip replacement and recovery for about 6 months, well into the COVID epidemic and so on. And as a result, I really haven't been able to do even much in the way of hobbies since I've been in Arizona. And Arizona has no what I would call development engineering at all. It has quite a few manufacturing plants, and it's kind of a hub for warehousing and trucking companies, for example, as well as, it used to be the base for Motorola Semiconductor Division and Honeywell. And during World War II, to decentralize, became the headquarters for Northrop Grumman and Douglas Aircraft and several of the other aircraft companies. And it has an abundance. Even now, there's 5 or 6 significant airports that were training fields for pilots during World War II. So, the only thing available till post-World War II were basically engineering jobs that were transferred from Southern California to diversify because they were afraid the Japanese were going to actually invade, if not just bomb, Southern California. So a lot of the industry was moved to California for that reason, and most of the aircraft training, pilot and crew training, was done at the small airfields in Arizona, as well as Patton's tank crew that was responsible for the operations in World War II in North Africa, all trained in the Arizona desert, about 100 miles from Phoenix, and so on. So the background, basically, the 3 C's of Arizona are cattle and basically copper as a dominant mineral, and tourism. There no real formal industry to speak of, other than what came here during World War II and to decentralize out of Southern California.
If you could do it over again, what would you change?
Well, I don't know. If I hadn't got hurt farming, I probably would have tried to continue farming, which is really about the only thing going on in the area where I grew up. At the time then, when I was into farming, our family probably owned about 240 acres of land, which was unusually large. A family could still make a decent living on 80 acres in the late 50s. But today, the minimum farm size to be able to justify the capital investment in equipment is at least 2,500 to 3,000 acres, which with land prices, nobody can afford. Most of the, in fact, a couple of the people that I went to high school with are in the farming business, and the family owns less than 100 acres, but farms well over 2,000 on a rental basis. And the livestock business has basically disappeared. There used to be a sort of a significant dairy business and hog production, pork production, and broiler chickens, and as well as laying chickens. But basically that has all pretty much gone away. The pork production has shifted to places like North Carolina domestically, and the state of Ohio basically made it impossible for a small dairy business to operate anymore. So far as I know, there are only 2 dairies left in Putnam County, Ohio, and they're sort of medium scale because of all of the requirements. You have to have refrigerated cooling and hot water available for sterilization and washing the dairy cattle before they can be milked, and all of that. It's a significant investment in capital equipment, let alone the labor to be in the dairy business anymore in the heart of the farming area of the Midwest.
Well, at least at this time, then, agribusiness isn't in your future.
I don't believe so. I decided to, when I was laid up in cast and traction in what would have been my second year of engineering school, that I probably was better off to get into engineering in a formal way rather than in farming.
Most of the engineering you've done has been in the area of rotating storage, which we all know is slowly declining, although it's unlikely to disappear. What's your vision of the future for computing and storage?
Well, really, most of my association from a development engineering point of view was in semiconductors and not in magnetic storage. Basically, I did some of the early work. IBM had a product line, a bipolar integrated circuit pilot line in San Jose, and I personally designed several of the integrated circuits that went into the 3340 and 3350 products, which then later, the San Jose semiconductor operation was really the pioneering one in the company on a production basis, at least. Some work was, of course, being done in research, but the main production semiconductor facilities within IBM that were the technology used in the System 360 and 370 were in upstate New York, and they were highly automated. For example, the wafer the standard process, production process, still in California, what's left of it, and in Japan and Asia, is that you probe a finished wafer at the wafer level, and you ink mark the defects that won't pass wafer test, and then you dice it and put the individual dice into a pot and assemble them into packaged integrated circuits. The IBM approach was entirely different. From the beginning, they did not do any wafer testing whatsoever. As soon as the wafer came out of the fusion, it was immediately diced and thrown into a pot. And the first operation is you attached balls to it. No wire bonds whatsoever. IBM never produced a wire bonded semiconductor, as the rest of the industry still uses. They attached controlled collapse solder ball bonds to the bare die before it was tested. It was only tested by an automated facility, which, because the balls were placed asymmetrically, it was a vibratory feeder that oriented the die correctly and probed it all without any manual intervention at all. It was all totally automated. And this is the way all of the production semiconductor products in the 3360 and 3370, and a lot of the stuff is still done today in the later, the 3390 disk drive and later mainframe computers. The semiconductor component was done and still is.
Right.
For example, the IBM PC was done by some renegade engineers in Florida as purchased conventional consumer electronic grade integrated circuits with plastic packages, wire bonds, and primarily DIP configuration, dual inline ones, which you could buy off the shelf from your local distributor. And no way, for at least a year, traditional IBM engineering facilities refused that stuff is not of a reliability class that it would be considered to be used in an IBM product. And the PC, the IBM PC, was considered a consumer product and not a data processing product. And one of its big limitations was the data processing sales force in IBM didn't know how to sell a consumer product like a PC. And that was one of the major problems. A good example is in East Fishkill, New York, at least probably a year and a half before IBM basically abandoned it. The primary manufacturer of handheld computers, high-end ones, was Hewlett-Packard. IBM built a prototype handheld calculator at least 2 years before HP shipped theirs that was far more powerful and was really a handheld computer, not a calculator. And it one of the specifications, it had to be the size that you could put it in your pocket, which was basically the requirement for the original HP calculator. But IBM didn't get in the calculator business because the sales force didn't know how to sell it. They were used to leasing selling leasing contracts for mainframe computers, big $1 million products, and also servicing them. They didn't know how to sell. I mean, the typewriter division was really not part of IBM. It was a separate division and a separate sales force, and it was completely separate from the data processing business.
One of the things that we talked about briefly was how engineering is changing, and what do you see? I think you've said that you see that a lot of engineers today can't actually design hardware.
That's true. Hardware is, from an electronics point of view, is basically dead. Everything is based on software and processors. There is discrete logic is obsolete, and the only thing that has some hardware component now is basically mechanical engineering sort of things. You still have to have a physical product to sell at a retail store, and that's basically what it is. And the change has been even more remarkable in the engineering schooling. There's no such thing as electrical engineering anymore. Or there's maybe a small branch here and there of a department in some of the smaller schools that sell ones that design things like motors and transformers and utility power equipment and transmission lines and so on. That's what you used to consider electrical engineering, but it's a very, the total output of that sort of engineers from the schools today, all in the U.S., is probably maybe 100 at best. And by comparison, it's probably 10 to 15,000 software engineers. And every department that used to be electrical engineering is now electrical engineering and computer science. And electrical engineering is maybe a couple old-time faculty members and a few hardcore students. But I would say probably there aren't more than 20 or 25 hardware electrical engineer, or I better state it as electronics based engineers in the world. And there's probably 50,000 software engineers. And today you're encouraged to become an electrical engineer, and yeah, that means a software guy.
Yeah. So, given that, what advice would you give a young person that's starting out in their career?
What I would say is don't become a software engineer where your training will be obsolete in a couple of years because they'll come out with a later release of the software project, and you don't want to sit 10 hours a day in front of a screen. You should get a broad-based background in all fields of engineering. Like one of the requirements when I started in engineering, you had to learn basic strength of materials, fundamental metallurgy, know how to draw things and construct a formal drawing, and do things like lettering and stuff like that, which is long gone. Now it's computer science and everything. You learn how to operate a keyboard, not to do a mechanical drawing.
Okay, Dal, you've been pretty quiet here.
Yeah, I've just been enjoying it.
Really?
Oh, yeah.
This is enjoyable.
Well, we don't get to reminisce very often.
That's probably true. Like I say, typically engineering schools now turn out several thousand electrical engineers a year, except maybe 15 or 20 hardware guys. And they're guys. There are very few, software people, there are some female software engineers, but they're not very significant. They're mostly still men like it used to be.
Well, in fairness, circuit design and modeling has replaced a lot of the hands-on stuff.
Well, what is considered engineering now is to enter parameters to some cookbook software that is used in an automated facility to construct the masks for a custom IC. That's as close as you're going to get to any hardware sort of work today, unless you're in a small startup company that, and to some extent, used to be things like automotive and industrial robotics. You still dealt with somewhat, hardware electronics.
Yeah,
but that's about it.
Most of the design today, though, uses multi-physics models, and
That's true.
You basically create the clone of the thing before you create it.
There are very few really circuit designers left. There's a few circuit designers that do the basic products worldwide, and today most of them are either in Europe or Japan. There still are some design folks for electronics sort of things in the U.S. But for example, Intel does not have a factory sort of fab to make hardware stuff in California at all. Their major fabs today are in Oregon, New Mexico, and Arizona, and Asia.
Yeah. Well, it's impossible to have a real fab in California because of the environmental requirements.
It is. It was really, I had forgotten. You get in the hotel, you got a limited water flow faucet on your sink in the bathroom. And the drivers, at least in this area, it's even worse in Southern California. Now, if I look back on it from And the people from Southern California that basically are the core of the year-round folks in Arizona are kind of a different. In Arizona, everything is a maximum of 25 or 30 years old. The city is laid out on a grid. Every half mile, the street is 4 lanes. And it's just a different environment. You get here and people cut you off. The drivers are really obnoxious in the way they treat you compared to Arizona. And, Phoenix is particularly, there's a lot of, poor drivers in the freeways in greater Phoenix as well. But I have a hard time coming back to the reality. I lived in San Jose for 50 years and got used to it and didn't realize how different it is than the rest of the world today.
Yeah, we have a second home in Tennessee, and it's radically different than here.
Yes, I'm sure.
Yeah. All right, well, is there anything else you'd like to add before we close?
Probably not. Hopefully, I'm not sure what value my reminiscences are to current engineering folks, but hopefully there'll be some value.
Well, and the purpose of this, in large part, is that we don't forget the history. The history part of the museum is something that shouldn't be overlooked. It doesn't really exist. Other museums, including stuff in Arizona, is a museum, and it isn't like things here at all. Right. Well, thank you so much, Dick. Really appreciate it.
Okay, you're welcome.
Enjoyed it very much.